Okay, I thought I'd walk you through the measurements lab. So what we're going to do in this lab is really focus on our measurements and significant figures and uncertainty. You're going to have two rulers here, and you can see one ruler has a few more markings than the other one, and that's going to determine how many sig figs we can measure with these rulers. So we have these four different rectangles here, and you're going to measure them with both of the rulers. You're going to measure the length and the width. Consider the length to be the longer side, and the width will be the shorter side. So whenever you measure the rectangle, the longer one is, record that as the length, and the shorter side as the width. All right, so you're going to record all that data, and then let me walk you through how to analyze it. Here we go. So I picked different rectangles than the ones that you have, just so you can see a different set of numbers. And for this one, the length was 11.5 and 1.5 for the width. Now again, this is not a real rectangle that's on your sheet. You'll do whichever ones, measure your own. So when you're measuring the length with that ruler number 1, so this is for ruler number 1, you can approximate one extra decimal place. So if we look at our ruler over here, you can see there are markings every centimeter. So if it's in between somewhere there, I'm going to approximate one decimal place. So this is 1. If it was between 1 and 2, I would, if it was right there, I would say it was like 1.5. So I'm going to approximate one extra decimal place with this ruler. For ruler 2, when I use that one, I'm going to be able to get 2 decimal places. I'll be able to read 1 exactly, and then the uncertainty is going to lie in that second decimal place. Okay, so for the first one, measured length, 11.5. There's 3 sig figs in that number. All the numbers that I'm able to record, including this 0.5, that's where the uncertainty lies, that'll count as one of my significant figures. For the width, I only have 2 decimal places. So let's put 2 down for our number of significant figures in the width. Only 2 there. 1, 2. And it will vary depending on how long your side was. So this one it was over 10, so I get an extra significant figure. Number of sig figs in calculated area. So area is length times width. So I'm going to multiply those two numbers. And when I multiply, I'm trying to figure out which one has the smaller number of significant figures, and that's what my product will be as well. So since this guy has 2 sig figs, this one has 3, 2 smaller than 3, my final calculated area is only going to have 2 significant figures. So when I multiply 11.5 and 1.5, so I did 11.5 times 1.5, I should get 17.25, and I'll round that to 2 significant figures, which would be 17. So that's how I do the first part. So you're going to do the same thing for the 4 rectangles that are on the table. This is for ruler 1, and that's to calculate the area. To find the perimeter is when you are adding up all the sides. So that's going to be the length. Right? How do we get to the perimeter? The perimeter is going to be it's going to be the length. The length plus the width. So we got length plus width, right? Length and width. Adding all those up. So for this, I have 11.5 plus 11.5 plus 1.5 plus 1.5, and that should equal 26. Right, so I'm just adding up 2 times the width, 2 times the length, get all that, it's 26. I have one, when I'm adding, I'm keeping a track of how many decimal places I have. So I have 1 decimal place in all of these, so I'll have 1 decimal place on my final answer. It just happens to be a 0, because 0.5 plus 0.5 plus 0.5, that, you get it, that's 0, so I have 26.0, that is the calculated perimeter. So I end up with 3 significant figures in my perimeter, because when I'm adding or subtracting, I'm keeping track of how many decimal places do I know. So everything, all the rectangles that you measure with ruler 1 are going to have 1 decimal place. You'll know 1 decimal place. For the second ruler, you'll be able to approximate an additional decimal place. So let's go back to that ruler so you can see what we have going on here. Here's our ruler. We have markings every every tenth of a centimeter there. So 1, and then this is 1.2, 1.5, all the way through there. So you're going to be able to approximate one extra decimal place. So we'll have 2 decimal places using ruler number 2. So that's where I got the 11.5 from. Again, this is the same rectangle I was, imaginary rectangle I was using before. It's different. You should not have the same numbers here for your rectangle A. So I have 4 significant figures in this number, and for the width it was 1.44 using ruler 2. So pretty close to ruler 1. I just able to approximate an extra decimal place here. And there are 3 significant figures in this number. So it's all of the numbers that I'm able to read off the ruler, including this second decimal place that's where the uncertainty lies. So when I'm calculating area, I'm looking at the number of significant figures in both of the numbers that I'm multiplying. This one has 4, this one has 3. 3 is smaller, so I'm going to have 3 in my calculated area. To find the area, I'm going to multiply these. I'm going to have 11.55 times 1.44. I should get 16.63. And if I round that to 3 significant figures, I look over here at this 3. 3 is less than 5, so I drop everything over here, and I end up with 16.6. So that's where I got my calculated area, my rounded calculated area. I'm going to do the same thing for my perimeter that I did before. I'm going to add up all these parts. So I have 11.55 plus 11.55 plus 1.44 plus 1.44. We should get this. And I have 2 decimal places. Everything in ruler 2, everything we measure using ruler 2 is going to have 2 decimal places. So yeah, when I add them up over here, I end up with 25.98, and I'm going to keep those 2 decimal places. It works out perfectly. I didn't have to round or anything. It's still 25.98. And that's about it. You have some post-lab questions to answer with that as well.